This is section 3.7, Arguments and Truth Tables. Finally, after learning all of the logic, after learning all the truth tables and everything else, we are finally going to get to use logic for its main reason. You're going to have an argument, okay? Meaning, you're making a case for something or you're drawing conclusions for something, not as in a fight. An argument consists of two parts. There are the premises, like the things that you assume to be true, and then a conclusion based off of those. Okay? Now, to be a valid argument, that is an argument in which the conclusion is true whenever the premises are assumed to be true. So in order to test validity, all we are literally checking is the logic of it. Now, you can start off with incredibly insane premises, and the logic can still be good, and you can get a bad conclusion based on that. But it's just the logic. If the premises are true, does your conclusion immediately fall from it every time? A sound argument is a valid argument that begins with true premises. So here, a valid argument, the logic is good. You may or may not actually have a good argument at the end, but the logic is good. Sound arguments start off with things that are true, and then they are valid, so the logic is true, so your answer is definitely true. An invalid argument, or a fallacy, is an argument that's not valid. Okay? A valid argument can reach a conclusion that is true, and a valid argument can reach a conclusion that is false. Remember, because if your premises are false, you may end up with something that is false, and the logic would still be good. Okay? So, how do we use truth tables to test whether or not an argument is valid? We are going to have to use a letter to represent each simple statement of the argument. We've had a lot of practice with this. We'll figure out what we're going to call P, what we're going to call Q, and so on. And then we're going to write them in symbols. We have a lot of practice with that as well. And then what we need to test at the very end on our truth table is something like this. We're going to take the first premise and the second premise and the third, the fourth, the fifth, however many we have, and those go in brackets. So it's if all of these premises are true, all of them, so that's why we have and in there, then the conclusion. Okay, so we're going to put something like this. I think this will make a lot more sense when you see an example problem. And in this right here, n is the number of premises you have. Okay, then we're going to construct a truth table for this conditional statement, which means we're going to have a lot of different pieces, but we'll get there. And then, how do we know if it's valid or not? If the final column, after we've tested this whole huge conditional, if the final column is a tautology, which means it's all true, then the argument is valid. If a false appears anywhere in that final column, it's an invalid argument. Okay, so let's look at our first problem. So this is the way our arguments are all going to be written. Above the line, that this is a premise, this is a premise. So not P or Q, P. So if these are our premises, then the conclusion we draw, remember the 3 dots means therefore. So it is the conclusion, therefore Q. Okay, so how do we what am I going to need to do here? I need to take this, and since the premises has more than one piece, I need to put it in parentheses. So that's premise 1 and premise 2. So it's if these with an and between them. Put that in brackets since there are parentheses inside. So if this, then Q. And that's what we need to test. So I'm going to go through and I'm going to build up the pieces I need here. I need a not P. So this is false, false, true, true. Okay. I need not P or Q. So not P or Q. And the only time an or is false is when they are both false. If there's a true anywhere, it is true. So the second one is false, true, and this one is also true. Okay. So now I have this, I need this and this. And remember, with and, they both need to be true in order for it to be true. So I have true and true. So this is true. If there's a false anywhere in this, then it's false. That's false, false, and false. So the only one that's true for this top is this top line right here. Now we're able to do the conditional. So it's if this column, then this column. And remember with the conditional, if you're starting off with a false statement, the conditional is true. So since this is the beginning and it's false here, all of these are true. Now I just need to check this top line, and it's if true, then true, which is true. Okay, so this is our final column. We ended up with trues all the way down, so this is a valid argument. It's actually of a special form that we'll be talking about a little bit later in this section.